Given the polynomial p of x, which is equals to x cubed minus 5x squared plus 8x minus 4, in this video, I'm going to evaluate p of x at x equals to 3, and then go on and factorize p of x. So what I've done here is I have created a live script and entered this text. So the next step that I will do is I will now go on and enter the code to answer these questions. So when I'm at live editor here, I'll go on and click here, then press the return key, and then press code, so that I enter the code to answer this question here of evaluating p of x at x equals to 3. And the first step is to write that polynomial there. What MATLAB does is it represents polynomials as raw vectors containing coefficients ordered by descending powers. So we are looking at coefficients of these variables there. So what you are having there, here the coefficient is a 1, here minus 5, here is an 8, here is a minus 4. So they are decreasing there for the powers, power 3, power 2, power 1, power 0. So I can go on and write our polynomial. P is equals to, write the coefficients as raw vectors. So it will be 1, and then minus 5, and then 8, and then minus 4. So that's our polynomial there, and I can go on and press the return key. We have now written our polynomial there. We go on and evaluate it at x equals to 3. And the function polyval evaluates the polynomial at a specified value. In this case, we are specifying at x equals to 3. So what I'll do is I'll type in polynomial evaluation. Then we are saying we are evaluating the polynomial p at x equals to 3. So specify 3. So it's p, 3. So that's what we need to do there. Then I can go on and just run here so that we see the output. So it's saying that our polynomial is this raw vector 1 minus 5, 8 minus 4. Then the answer of evaluating the polynomial at x equals to 3 is a 2. So this is one way of evaluating the polynomial at x equals to 3. There's another method where we use the symbolic variables. So what you can do is we can create a polynomial expression using a symbolic variable. So what I would do is we create a symbolic variable sy m s symbolic variable x, then go on and write our polynomial, this polynomial here, using the symbolic variable. So I'll call that p2, just to make it different from the p that we had there. So p2 is equals to, then you are typing x to the power 3 minus 5, and then times x squared, then plus 8 times x minus 4. So this is the polynomial when you are using the symbolic variable x. Let me just run this. So you see that our p2 is x cubed minus 5x squared plus 8x minus 4, which is the same as the polynomial that we want here. So I will now go on and evaluate the polynomial that we have just entered here at x equals to 3. When you are using the symbolic version of the polynomial, what we will use is the function subs. And the function subs evaluates the polynomial at a given value. Let me call the evaluation e. So I'll say e is equals to subs, and open parenthesis. We are substituting into the polynomial p2 of the variable x. We are substituting wherever we have x, we are putting 3. So it's x, then comma 3. So I'm done with this. I can just run this so that we see the result there. Subs p2 x3, and we are calling that result e. So we see that the e there is a 2, which is expected as what we got here. The answer was 2, but I was just giving now another option of evaluating this polynomial at x equals to 3 when we are using symbolic variables. So I can now go on to this question here of factorizing p. So I press the return key. So what we are factorizing is I'll factorize the expression that I entered using symbolic variables, the p2 there, which is the same expression as this one anyway. So I'll go on to code, and the function that we use is factor. So it's factor, open parenthesis, and we are factoring the polynomial p2, the one that I entered using symbolic variables. So we are finding the factors of p2 there, and then I'll go on and click run section here. And it's giving us there the solution there. We are having the factors x minus 1, x minus 2, x minus 2. So what we'll be having there is when we factor the polynomial there, we get x minus 1 multiplied by x minus 2 multiplied by x minus 2. And from there we can see that the roots there are x equals to 1, x equals to 2, and 2 will be a repeated root.